So students, welcome back. We are doing certain problems of nuclei chapter. Chapter name nuclei, the main topics are done. Now let's see. Question. The ratio of the nuclear densities and radius of two nuclei having mass numbers 64 and 125 will be dash comma dash. Okay, please type your answers. We have discussed this topic, so please type your answers. All of you, good evening. Srinanda, Kriba, Amrita, Anaga, Aishwarya, Vishnu Prasad, Nimisha, Aliya, Ajit, Drishya, Vandana, Abhay Krishna, Shifana, Naveen. All of you, good evening. Please type your answers. First, ratio of nuclear density. Next, ratio of radius. Nuclear density is what? It is a constant. It is independent of mass number and atomic number. So nuclear density is 1:1. What is the equation for radius of a nuclei? R equal to R0 A raised to 1 by 3. So R1 is equal to R0 A1 raised to 1 by 3. R2 is equal to what? R0 A2 raised to 1 by 3. So what is R1 by R2? It is that thing we have to find out. So R0 gone. A1 is what? Instead of A1 what we have? 64 whole raised to 1 by 3 divided by A2 is what? 125 whole raised to 1 by 3. What is 64? 4 cube raised to 1 by 3. What is 125? 5 cube raised to 1 by 3. So what happens? 3 gone. What is the ratio? 4 by 5 or 4:5. Any doubt? Any doubt? മനസ്സിലായോ? Is it clear? Is it clear? മക്കളെ മനസ്സിലായോ? Yeah. നോട്ട് ചെയ്യട്ടോ. നോട്ട് ചെയ്ത എല്ലാവരും? നോട്ട് ചെയ്തോ? നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ. Two nuclei have mass numbers in the ratio 1:27. What is the ratio of nuclear density? What is the ratio of nuclear density? Type your answer. Mass numbers ratio is given. What is the ratio of nuclear density? What is the answer? Next, these all are previous NEET question. Another question. The ratio, here answer will be what? 1:1. Since it is nuclear density, it is a constant. The ratio of nuclear density of 40 Ca and O16 is dash. Again answer is what? 1:1. Again nuclear density is independent of mass number and atomic number. നോട്ട് ചെയ്യട്ടോ, ആ ക്വസ്റ്റ്യൻസ് ഒക്കെ നോട്ട് ചെയ്യേ. എപ്പോഴും ന്യൂക്ലിയർ ഡെൻസിറ്റിയുടെ റേഷ്യോ ചോദിച്ചിട്ടുള്ള ക്വസ്റ്റ്യൻ കോമൺ ആയിട്ട് കാണുന്ന ക്വസ്റ്റ്യൻ ആണ്. ഈ പ്രോബ്ലം ചെയ്തു, ഈ പ്രോബ്ലം ചെയ്തിട്ടുണ്ട്. ഈ ഗ്രാഫ്സ് കഴിഞ്ഞു. Next is section. Calculate the binding energy of an alpha particle in MeV given mass of proton 1.007825 AMU. Sometimes they won't write AMU, simply U. Mass of neutron 1.008665 U. Mass of the nucleus is given and 1 AMU is what? 1 AMU you should take 931.5 MeV. First of all, we should know an alpha particle contains what? An alpha particle contains what? 2 protons and 2 neutrons. So what is mass of 2 proton? Mass of a proton in AMU unit is already given. So mass of 2 proton is found out. Mass of 2 neutron is found out. Then we will find out total mass. This is the expected total mass, 4.032980 U. But what is the actual mass? Actual mass of the nucleus is for 4.002800 U. That means what? There is a mass defect. Mass. This is the expected total mass and this is the actual mass. Actual mass is lesser than the expected mass of the nucleons. That means actual mass is lesser than the expected mass. Why there is a difference? Because of mass defect. How mass defect is found out? Total mass minus mass of the helium nuclei. And its value is what? 0.030180 U. So what is the binding energy of alpha particle? How to find out binding energy? How to find out binding energy? Mass defect in AMU into C square. Mass defect in AMU into C square. That C square is what? That C square is, if you solve that, energy equivalent of 1 AMU is what? 931.5 MeV is the standard formula. But in the given problem, they are telling you that mass defect in AMU into 931 MeV. Into what? 931 MeV. Into 931 MeV. So that is the answer for mass defect. Doubt in the step doubt in the separate cheyana. നമ്മളത് മുമ്പ് ചെയ്തിട്ടുണ്ട് ഈ ടൈപ്പ്. Those who have finished can try the next problem. Those who have finished can try the next problem. Same type only, not much difference. Same type only. Next, calculate the bind energy per nucleon of 26 Fe nucleus. Given that mass of F is given, that is actual mass of neutron, mass of proton is given. So first of all, you should find out total mass of proton. So how many protons are there? 26 protons. So 26 into mass of a proton, which will give a total mass of protons. Then total mass of neutrons. How many neutrons are there? 56 minus 26, that is 30 into mass of a neutron. If you solve that, you will get what? Total mass of neutrons. Then you will find out what? Total mass of the nucleus. That minus actual mass will give you what? Binding energy. Sorry, that will give you what? Mass defect in AMU. That into 931.5. It is not given. The data is not given what to take for 1 AMU. So you should take the standard answer, which is 931.5 MeV. In some questions, they will give you 931 MeV. Then you should take 931 MeV. It is not, if it is not given, then you should take 931.5. The correct value of energy equal to 1 AMU is 931.5 MeV. കഴിഞ്ഞാ കിട്ടിയാ നോട്ട് ചെയ്ത് കഴിഞ്ഞാൽ എല്ലാവരും അത് ചെയ്താ ബൈൻഡിങ് എനർജി കാൽക്കുലേറ്റ് ചെയ്താ? Anybody got it? Please type your answers. സോൾവ് ചെയ്തിട്ട് ആൻസർ ടൈപ്പ് ചെയ്തിട്ട് എല്ലാവരും. So total mass of neutrons, total mass of nucleons found out, mass defect, combined mass of nucleon minus mass of 26 Fe, then bind energy. See, it is taken 931.5. But the exact answer is 931.5 MeV. But even if you are taking 931, it's okay. Then you will get bind energy 492.71 MeV. Then bind energy per nucleon is equal to what? 492.71 divided by 56. Answer is 8.79 MeV per nucleon. finish ചെയ്യേ. കിട്ടിയാ ദേവിക? Did you get that? See, it's a lengthy problem, but it is a very important problem for entrance and also for important problem for JEE and also for NEET. Others, please finish. This question is very important. എല്ലാവരും അത് ഫിനിഷ് ചെയ്തു എന്ന് വിചാരിക്കുന്നു ഈ പ്രോബ്ലം. സോ നെക്സ്റ്റ് പ്രോബ്ലം ഇതെല്ലാം ചെയ്താണ്. ഫിഷൻ ഇത് ചെയ്താണ്. ഈ പ്രോബ്ലം ചെയ്തു. ഇതും ചെയ്താണ്. ഈ കോൺസെപ്റ്റ് ഒക്കെ പറഞ്ഞു. ഈ പ്രോബ്ലം calculate the radius of 13AL 27 nucleus. Is it done? What is the formula? R equal to R0 A raised to 1 by 3. So R0 is what? 1.2 femtometer. Mass number is what? 27 raised to 1 by 3. So what is 27? 3 cube raised to 1 by 3. So 3.6 femtometer, which is 3.6 into 10 raised to minus 15 meter. Any doubt? Doubt now? So that is done. Next, protons are not used in nuclear reaction. That is done. Why protons are not used in nuclear reaction? Protons are positively charged particles, hence they experience what? Repulsion from the target nuclei. So very high energy is needed for a proton to make a collision with the target nucleus. Why protons are not used? Because we have to spend extra energy to overcome the Coulombic repulsion. Why neutrons are used? Since neutrons are uncharged particles, they do not experience any repulsion from the target nucleus, so they need very less amount of energy to collide with the target nucleus. അതറിയണല്ലേ? ഒന്നുകൂടി പറയുമോ? Okay, why protons are not used? Suppose this is nucleus. This nucleus contains what? Protons and neutrons. Not this nuclei, all nuclei contains protons and neutrons. When you use a proton to induce a nuclear reaction, these two protons will have Coulombic repulsion. These two protons will have Coulombic repulsion between them. So we have to spend extra energy to overcome this repulsive force. So that is the reason why we are not using protons in nuclear reactions. Please note it down. I think I have discussed that in the previous class, because I have told you it is not easy to conduct nuclear fusion. Nuclear fusion is not easy to conduct. Why? Because two protons will means two nuclei will have protons. There will be proton-proton Coulombic repulsion. So you have to spend extra energy to overcome this Coulombic repulsion. നോട്ട് ചെയ്യട്ടോ. അഭയകൃഷ്ണ ക്ലിയർ അല്ലേ? അടുത്തത് വൈ ന്യൂട്രോൺസ് ആർ യൂസ്ഡ് ഇൻ ന്യൂക്ലിയർ റിയാക്ഷൻ. ഇത് ചോദിച്ചിട്ടുള്ള ക്വസ്റ്റ്യൻ ആട്ടോ. കേരള സ്റ്റേറ്റ് പരീക്ഷയ്ക്ക് ചോദിക്കാറുള്ള ക്വസ്റ്റ്യൻ ആണ്. CBSEക്ക് ചോദിച്ചിട്ടുണ്ട്. Neutrons are commonly used to trigger nuclear fission. Why? Since neutrons are uncharged particle, they do not experience any repulsion from the target nuclei. So they need very less energy to collide with the target nucleus. So that is the reason why we are using neutron for nuclear reactions. Done. So next question. Yeah, calculate energy released in fusion reaction 1H1 plus 1H2 implies 2He3 plus neutron, where binding energy of 1H2 is 2.23 MeV and of helium is 7.73. This case there is no binding energy. It's a single neutron, no binding energy. So energy released. See, this might be confusing for it's a single neutron, so no binding energy. So energy released is what? Always remember in nuclear reaction, listen, this question is very tricky one. Always remember in nuclear reactions, the result or product will have more binding energy. That is the purpose of nuclear reaction. Always product will be having more binding energy. So binding energy of products, so what is the energy released? Binding energy of products minus binding energy of reactants. So what is the binding energy of products? Binding energy of 3He2 plus binding energy of neutron minus 2 times binding energy of 1H2. Why? Because there are two 1H2. So what is binding energy of helium? That is given 7.73 in MeV. MeV is taken common. Binding energy of neutron is what? 0, single neutron. 2 into binding energy of 1H2 is what? That is also given 2.23. 1H2 is 2.23 MeV. Since 2 1H2 is there, 2 into 2.23. So 7.73 minus 4.46. So what is answer? 3.27 MeV. Any doubt? മനസ്സിലായോ? ക്ലിയർ ആണോ? അബൈ ക്ലിയർ ആണോ മോനെ? ഇത് പ്രീവിയസ് ക്വസ്റ്റ്യൻ ആട്ടോ, ചോദിച്ചിട്ടുള്ള ക്വസ്റ്റ്യനാ. തന്നെ ചെയ്യട്ടോ, കാൽക്കുലേറ്റ് ചെയ്ത് തന്നെ ചെയ്യേ. Yeah, next question. For a given nuclear reaction, the binding energy per nucleon of the product nucleus or nuclei is more than the original nucleus or nuclei. See, product is having more energy than original nuclei. That means what? Mass have been converted to energy. Is this nuclear reaction exothermic? What is it by exothermic? Energy, heat releasing, endothermic is what? Heat absorbing. Answer. The given nuclear reaction is what? Exothermic. Why? Because there is a release of energy. The increase in binding energy per nucleon implies that more mass have been converted into energy. Increase in binding energy means what? More mass have been, more amount of mass have been converted to energy. This will result in the release of energy. Exothermic, heat releasing, endothermic, heat absorbing. Please note down. This ചോദിച്ചിട്ടുള്ള ക്വസ്റ്റ്യൻ ആടാ. കഴിഞ്ഞ കൊല്ലത്തെ CBSE ബോർഡ് എക്സാമിന് ചോദിച്ച ക്വസ്റ്റ്യൻ ആണ്. 2024 CBSE ബോർഡ് എക്സാം ക്വസ്റ്റ്യൻ ആണത്. CBSE 2024 ബോർഡ് എക്സാം ക്വസ്റ്റ്യൻ ആണ്. നോട്ട് ചെയ്യട്ടോ. നോട്ട് ചെയ്തില്ലേ നിങ്ങൾ? Next, how many electrons, protons, neutrons are there? How many electrons, protons, neutrons are there in a nucleus of atomic number 11, mass number 24? ഇത് ചോദിച്ചല്ലോ ഇത് കേരള ബോർഡ് പരീക്ഷയ്ക്ക് ഇതൊക്കെയാവും ചോദിക്കുക. എന്താ number of protons or electrons? Atom number is 11. So number of protons or electrons is what? 11. Number of neutrons will be what? 24 minus 11. That is equal to what? 30. Note here. Next, how many number of protons and neutrons in 56BA? Number of protons is what? 56BA. Number of protons is what? Atomic number, Z equal to 56. Number of nucleons is what? Number of nucleons. What is number of nucleons? Number of protons plus number of neutrons. That is equal to what? 144. So what is the number of neutrons? Number of neutrons is equal to what? 144 minus 56. You can type your answer. Number of neutrons. See, state question paper, you can expect this question in 1 word or 2 mark question. Previous state previous question. What is the answer? 88. Done? Noted? കഴിഞ്ഞോ? 88 done. Write the number of protons and number that is done. Nuclear density of gold isotope. Nuclear density will be what? It's a constant 2.3 into 10 raised to 17 kilogram per meter cube. It is independent of mass number and atomic number. Yeah, do this question. What is the nuclear radius of 125 Fe if that of 27 aluminum is 3.6 Fermi? See, aluminum nucleus radius is given. We have to find out the nuclear radius of 125 Fe. Actually, there is a better method because R equal to R0 raised to 1 by 3. This data is irrelevant. It is not required because if you know the mass number, you can simply find out the radius. Because R equal to R0 1.2 femtometer into mass number is what? 125 raised to 1 by 3. So R equal to what? 1.2 femtometer into, instead of 125 I can write what? 5 cube whole raised to 1 by 3. So what is R? 1.2 femtometer into 5. So answer is what? 6 femtometer. Answer is what? 6 femtometer. So I hope it is done. So next question. Yeah, if 200, it's a tough one, 200 MeV energy is released in the fission of a single nucleus of 92U235. If it is not clear, 92U235. How much energy is released from a single nucleus? 200 MeV energy. How many fissions must occur to produce a power of 1 kilowatt? It's a previous entrance question. How much fissions need to be done to produce a power of 1 kilowatt if energy released from the fission of a single uranium 92U235 is 200 MeV? നമുക്ക് എത്ര പവർ വേണം? റിക്വയർഡ് പവർ ഈസ് വാട്ട്? 1 kilowatt ആണ്. That is equal to what? 1 kilowatt. 1 kilowatt equal to what? 1000 watt. Then number of fission. How we are doing? Let the number of fission be n. Number of fission required be small letter n. Then in energy released per second will be what? See, what is the energy released per second? Number of fission. What is the? We are calculating energy released per second. What is the? How it is calculated? How many fissions are there, which is small letter n, and what is the energy of one fission? 200 MeV. So that converted into what? Joule. So 200 into 1.6 into 10 raised to minus 19. Energy released per second is equal to number of fission number of fissions into energy from one fission. So number of fissions small letter n, energy from one fission is what? 200 MeV, which is n into 200 into m is 10 raised to 6, ev is 1.6 into 10 raised to minus 19. So it becomes what? n into 200 into 1.6 into 10 raised to minus 13. Manasilayo? That much joule. That is energy released per second. Energy released per second. Energy required per second is what? Energy required per second. That is power into time. Remember, power is equal to work done by time or energy by time. Work done or energy by time. Now, energy per second is equal to what? Energy per second is equal to what? What is the equation? Energy per second is equal to what? Power into time. Energy per second is equal to what? This is not good. Energy per second is equal to what? Power into time. So, power is what? 1 kilowatt into time is what? 1 second. That is equal to what? 1000 joule. So, n into 200 into 1.6 into 10 raised to minus 13. N into 200 into 1.6 into 10 raised to minus 13 should give a power of what? 1000 joule. Not power, energy. 1000 joule. Here also joule. So what is N? 1000 divided by 200 into 1.6 into 10 raised to minus 13. If you solve that, you will get the answer 3.125 into 10 raised to 13. Manasilayo? Manasilayo? Doubt na? Devika clear ano? Devika clear ano? Namalenda energy released per second kandupidikunu, then we finding out energy required per second. Then we are substituting for n. Is it clear? Okay. Problem. Obtain the binding energy of nitrogen nucleus given mass of 7 and 14. Mass of 7 and 14. Given what is the atomic number? 7. And mass number is what? 14. What is number of neutron? 14 minus 7 equal to 7. So what is mass defect? Mass defect is what? Total mass of nucleons minus mass of the nucleus. Mass of the nucleus is given in the question. Mass of nucleons you have to find out. Given atomic mass unit is equal to what? 931.5 MeV. Cheetah. Thank you. Nuclei chapter we have done all the problems of nuclei chapter. So we are finishing today. Next class I will be starting dual nature. Okay, next dual nature is chapter atoms chapter. So next class we will be doing dual nature. So thank you all of you. Thank you.